This is the part 2 of section 9.3. Here I will explain abstract classes and interfaces. Actually, interfaces were the topics in section 7.5, but I was skipped at the time, so now I will explain abstract class and interface together. An abstract class is a placeholder in a class hierarchy that represents a generic concept. An abstract class cannot be instantiated. This is important concept. An abstract class cannot be instantiated. This means that we cannot create an object from an abstract class. We use the modifier abstract on the class header to declare a class as abstract. So this is a public class and you can write abstract here. Okay? Then this means that this class product cannot create an object. Only class and method can be declared as abstract. There is no abstract data member or constructor. Okay, so only you can put abstract keyword in front of the class or in front of the method. An abstract class can have member variables, constructors, and methods just like a regular class. An abstract class often contains abstract methods with no definitions. Abstract method must look like this: public, abstract, and there is no body, there is no definition. It means that there is no brace. Okay? So usually we have method header and we have brace like this, right? This is a definition. The abstract method does not have this one. Instead, abstract method should finish with semicolon. Okay, finish with semicolon. So, abstract methods have no body part, does not have a brace part, and must end with a semicolon. Okay. Also, an abstract class typically contains non-abstract method with full definitions. So abstract class can have general methods with a definition, and also abstract class can have abstract method that look like this. Okay, that looks like this. A class declared as abstract does not have to contain abstract methods. Simply declaring it as abstract makes it so. But this time, this class cannot make an object. You can create an abstract method like this. When you create a file, check this one. Okay, check this one. Then automatically the Eclipse will show you like this. We'll make a class header like this. Okay. This is an abstract class example. As you see here, this class is an abstract class. It defined like this. It has member variables and constructor and general methods. And this is an abstract method because there is no body, there is no brace, and it finishes with semicolon. Okay. So here, an abstract class can have member variables, constructors, and methods like regular class. An abstract class often contains abstract method with no definitions. Okay. And let's see this one. This time there is no abstract method, right? There is no abstract method and just like normal classes. But this class is declared as abstract. Okay, this is okay. Okay, so a class declared as abstract does not have to contain abstract methods. However, we cannot create an object with this class. Okay, so look at here. I try to make an object of this abstract test class. So this is a constructor. This is a constructor. So I try to make an object using this constructor new abstract test, and there is one parameter, integer parameter, but this is an error. This is an error, and this is the error message. Cannot instantiate the type abstract test. Okay, so once you declare the class as abstract, then you cannot create an object from that class, regardless of it has a abstract method or not. This is important. If there is an abstract method in the class, then the class must be declared as abstract. Look at this example. This class is not declared as abstract, but this class has abstract method like this. Okay, then the compile error will occur. Okay, if there is an abstract method, then the class must be declared as an abstract class. The error message is like this. There are two errors. Error will be occur here and occur this place. Okay, occur here and occur here. And the error says the type abstract test must be an abstract class to define abstract methods. And the error, one error occurred here. The error says the abstract method test, the test, this one, in type abstract test can only be defined by an abstract class. Okay, so be sure that if there is an abstract method, the class must be declared as abstract. Since abstract classes cannot create objects themselves, child classes are required. Child class inherits abstract class and makes body of abstract method using overriding. The child of an abstract class must override the abstract methods of the parent, or it too will be considered abstract. Okay, this is important. An abstract method cannot be defined as final or static. You know what final is? What is final? If you put final in front of the method, it means that the method cannot be overridden from the child class. Okay, and static means that static method will be shared by all the objects. Okay, so static method can be called without creating objects. So we usually call static method by class name dot the method. Okay, so be sure that abstract method cannot be defined as final or static. The use of abstract classes is an important element of software design. It allows us to establish common elements in a hierarchy that are too general to instantiate. Let's see this example. Public abstract class, abstract parent. Abstract parent is an abstract method. It has member data, constructor, and general method, and abstract method. See here, this is an abstract method. So this class has one abstract method, and this is the abstract child class. This class extends abstract parent. This means that abstract child class can use the members of abstract parent. Okay, and this is the constructor, and as you see here, using super keyword, the child class calls a parent class constructor. And this one, public void print. This header is exactly the same as this one. Okay, public void print. So see here, public void print. Okay, so public void print, and then it has brace and definition of the code. Okay, definition of the method code like this. This is overriding. Okay, so if the class inherits from the abstract class like this, then the child class must override all the abstract methods like this. So the child of an abstract class must override the abstract methods of the parent. Okay, let's look at this example. there is an abstract method, abstract class, abstract parent. It has one data member, constructor, and one show method, and abstract method print. Okay, and then abstract child class inherits from abstract parent class. And abstract child class has its own constructor and check method. As you see here, there is no abstract method here, but the child class did not override parent abstract method print. The child class did not override this one. Then the child class inherits the print method in an abstract state. Can you understand what I'm talking about? In other words, abstract method exists in this child class. You can think that this is an abstract child class after inheritance. As you see here, this is from parent, and constructors are not inherited to the child, so we don't have to think about constructor. Show method is inherited to the child, okay? And this one also inherited to the child, okay? But the child class does not override this print method. So print method exists like this, just abstract print method. This means that this class, this child class, also has print method as abstract, okay? Then the class must be declared as abstract. Can you understand? This class, child class, inherits from this parent class, and this child class does not override abstract method that are in the parent class, for example, like print, like this one. Then child class also must be declared as abstract because it has abstract method from the parent. Okay? This is an important, so make sure this is situation. Let me explain why we need abstract methods and abstract class. Here, parent class looks like this. This is not an abstract class. This class has two methods, show and print. And there are two child classes, two child class like this. And this is child 1 class. It has print method. So this child 1 class overrides print method. And here is child 2 class. Child 2 class also overrides the print method. Okay. Then let's see the example. This is a simple UML diagram of the previous code. This is parent class that has a show and print method, and child 1 inherits from this parent class and it has print method. This is overriding. And the child 2 class also has a print method. This is also an overriding. In this situation, in the main class, two objects of the child class are created like this. X is the object of child 1, Y is the object of child 2. And if we call X the show, then X is child 1 object. Then X will see if there is a show method in its own class here. There is no show method, then X will look for the parent class. Okay? So if there is a show method in the parent class, then this method is executed. Likewise, Y the show, since Y is a child 2 class, Y sees if there is a show method in the child 2 class. But there is no show method, then the object will look for the parent class. Okay, so there is a show method in the parent class. So here also parent show method will be executed. Okay, so parent show are printed out like that. And here x.print, then the object X will see if there is a print method in its own class. This time, there is a print class in child1 class, right? So, this print is executed. This print is executed. And then, why the print? This is also Y is a child2 class object. So this class also has print method like this. So Y the print also print this one, execute this method. Okay. Then in the case, parent class print method cannot be called. Just a second. Okay. As you see here, okay, parent class print method cannot be called by its child class in this situation, since it is overridden in the child class. In this case, the body of print method in the parent class is useless. Okay, so we can make it an abstract method. And if there is an abstract method in a class, the class must be declared as an abstract class. Can you understand this one? This is very important. This is why we make an abstract method and abstract class. Okay, here this is the parent class. In the previous page, parent class has show and print method. And because this print method is overridden in the child class, we don't have to write the body of the print method like this. So we can make this print method as abstract like this, because we don't need the body of the print method. And if there is an abstract method in the class must be declared as abstract. Okay? So this is why we need abstract method and abstract class. Let's see this example. Here is an abstract class person. It has one member data and constructor and one abstract method show. And student class is a child of person class like this. It has one data member and constructor. Inside the constructor, it uses super keyword to call the constructor of parent. Okay, so this will call the parent constructor. And this method show is overriding, right? So this method is overridden from the parent show method. And in the main method, person object is created like this, but this is an compile error, right? Because person is an abstract class, person cannot make an object. So this is a compile error. And this one, S is the object of a student class. This is okay. This is okay. And if S calls as the show, then this show will be called. Let's see this example. I have already explained to you that parent abstract method must be overridden in the child class. Otherwise, the child class must also be declared as an abstract class. This example shows this one. Parent class is an abstract class. It has a show method. This is a general method. And call method is an abstract method. And here in the child method, there is only one method, print method. So this means that this abstract method is in the child class. Okay? Because there is no overriding call method. So this is an error. Okay? If the parents class has an abstract method, then the child method must override the method. If the child method does not override the method, then the child class should be declared as an abstract. Okay? And this is the error message. the type child must implement inherited abstract method parent call. Okay. There are two ways of fixing the previous compile error. One is that just overriding the abstract method in the child class. So abstract parent, and there is an abstract method call, and child class will overriding the call method like this. Okay, then the compile error will disappear. And fix number 2. This time we can make the child class as abstract. Okay. However, if we declare child class as abstract, then child class cannot create an object. Okay. But anyway, if we can do this, then compile error will disappear. Okay, because if the child class does not do overriding the call method, then it's like the child class has this abstract method inside its class. Okay, so we can declare child class as abstract. Then the compile error will disappear. Let's see this example again. This is a parent class, and it has abstract method like this. Okay, this is a class parent, and this is an abstract method. Yes, and there is a two compile errors. A compile error will occur here and will occur here. Okay, so the compile error here says the type parent must be an abstract class to define abstract methods. Okay, so compile error will occur here, and this compile error will occur here. Okay, the abstract method shown in type parent can only be defined by an abstract class. Okay, so a class with abstract methods must be declared as an abstract class. Okay, so you must be careful. Abstract class can have normal method. Okay, but if the class has an abstract method, then the class must be declared as an abstract class. Okay, let's do some quick check. What are some methods defined by the object class? I explained two very important methods. One is toString and the other is equals, right? So public string toString, public boolean equals, and object. Okay, what is an abstract class? An abstract class is a placeholder in the class hierarchy, defining a general concept and gathering elements common to all derived classes. An abstract class cannot be instantiated. Okay, and I explained a lot about abstract class. So I hope you understand everything, and if you don't understand, then just go through the examples I provided. Okay. Now I will introduce interface. A Java interface is a collection of abstract methods and constants. So interface is some special case of abstract class. A Java interface cannot have a constructor. An abstract method can be declared using the modifier abstract, but because all methods in an interface are abstract, usually it is left off. An interface is used to establish a set of methods that a class will implement. I will explain this more in detail. This is an interface example. Interface should have interface keyword like this. So public interface, and this is the interface name. This interface has 4 members. 2 are data members and 2 are methods. data members in an interface must be declared public static final. Okay, so the member variables in interface must be a public static final variable. Okay, so this is a constant, right? Because there is a final keyword here. So the member data in the interface are all constants. And methods in an interface must be declared public abstract. Okay, so that's why there is no body part here, no braces, or just end with semicolon. Okay, so in interface you can have constant member data and abstract method. This interface has two data members and two methods. And I told you the data must be declared as public static final, and the method should be declared public abstract. Right? So because all of the data members should be declared public static final, we can omit this keyword. Okay? Public static final can be omitted in the declaration of member data. So we can write just like this. These two are the same. Okay, these two are the same. And likewise, the methods in the interface are declared public abstract. So we can omit public abstract may be omitted in the declaration of methods. So we can write just like this without public abstract. Okay. So even if there is no public abstract here, this method is public abstract method. And even if there is no public static final here, this data is declared as public static final. Okay? So simply you can write like this. Okay. None of the methods in an interface are given a definition. Interface is a reserved word. And then you can write like this. And there is no body. There is no body, right? There is no body and there is no body. A semicolon immediately follows each method header. Okay? You can also omit this public. You don't have to write public. Okay? Like abstract class, since interface has abstract methods, interface should have child class. To have an interface as a parent, we should use implements keyword like this. So this means that class will have doable interface as its parent. Okay? And we can assume that these methods are overriding from the abstract method in the doable. Okay? So anyway, the important thing is that this keyword implements. So class implement interface. When a class inherits from class, extends keyword is used. So here, class parent, class child extends parent. Okay, so class can inherit from class using extends keyword. When a class inherits from interface, implements keyword is used. Here, interface parents and class child implement parent. Okay, this time parents is an interface. So you need to use implements keyword when class child inherits from interface. Interfaces can also inherit interfaces. In this case, extends keyword is used. Okay, see here, this is interface parent. Interface also have its parent, interface parent. At the time, we need extends keyword. So interface child extends, this is also interface. Okay, so extends keyword will be used between child interface and parent interface. An interface cannot inherit a class. Okay. Let's make an interface. If you want to make an interface, choose new and interface. Then you can have this icon like this. So there is a small I, so it means interface. Let's see this example. This is an interface doable. It has 4 abstract methods, and this class can do implements doable. So this interface is a parent of this class. Okay, so this class has 4 methods. All of these methods are overriding methods from the parent doable. Okay, so do this is from do this. So do this is overridden here, and do that is overridden here, and likewise do this too is overridden here, and do the other is also overridden here. Okay, so completely can do class has overridden all the methods. And here is main method. In main method, the object of can do class is created like this, and then can dot do this. So can calls this one, and do that will execute this one, and then do this do the other is this one, and do this too is this one. Okay, so this is nothing special, just I want to show you that the grammar of how to use interface and how to overriding the methods in the interface. Let's take a look at this example. This example is the same as the previous one, except that in can do class there are only 3 methods, 3 overriding methods. So here, do this too. This method is not overridden in class can do. Okay, so this means that can do class has 1 abstract method. So actually this method, this do this too, this method is in the class can do, right? Because can do implements doable. Okay, so since can do has 1 abstract method inside the class can do must be declared abstract. Like this. So do this too method is not overridden, then class can do has the abstract method do this too. Therefore, can do class must be declared as an abstract class. In addition to abstract method, an interface can contain constants. I told you interface can have public static final value. That is a constant. When a class implements an interface, it gains access to all its constants. A class that implements an interface can implement other methods as well. Let's see this example. This is an interface, my interface, and class, my class, implements my interface. So in this class, these 2 methods, they are abstract methods. So these 2 methods are overridden in the child class, like this. And this test method is not related with my interface. So like this, a class can implement other methods as well. Okay. I told you before that in Java, multiple inheritance is not allowed. It means that any class can only inherit just 1 parent class. However, a class can inherit multiple interfaces. So here, a class can implement multiple interfaces. The interfaces are listed in the implements clause. So you can write like this: class, the class name, implements, and interface name. Okay, using comma, you can list interface like this. Then this class inherits from both this interface. In this case, the class must implement all methods in all interfaces listed in the header. Okay, so inside many things, the methods in interface 1 should be overridden, and likewise, methods in interface 2 should be overridden in this class. Because interface can inherit from interfaces, there is a hierarchy in interfaces. Inheritance can be applied to interfaces. That is, one interface can be derived from another interface. So interface is the parent, and also interface is the child. The child interface inherits all abstract methods of the parent. A class implementing the child interface must define all methods from both interfaces. We have seen this example before. Yes, I told you like this. And this is multiple interface inheritance. So this is the class and implements, and this class wants to inherit from two interfaces, from interface 1 and interface 2. Then we can write like this, implements, and using comma, you can list interfaces. A child class can have at most one parent class and can have multiple parent interfaces. So here, many things, class many things, has one parent class, this one parent class. So since this is a class, we use extends keyword, and then two parent interfaces. So implements, interface 1 and interface 2. You need to write like this. Here you should be careful that you must write extends first. Okay? So extends class, and then implement interface. You must write like this. Let me introduce iterator interface. An iterator is an object that provides a means of processing a collection of objects one at a time. An iterator is created formally by implementing the iterator interface, which contains three methods. One is hasNext, and the other is next and remove. hasNext method returns a Boolean result, true, if there are items left to process. Next method returns the next object in the iteration. The remove method removes the object most recently returned by the next method. Here we will use hasNext and next method. I'll show you how to use iterator interface. At first, let's see this example. You know array list. Here I made array list called list, and the array list has a string object like this. And then using add method, I add 5 strings into array list. So C++, Java, HTML5, Python, and JavaScript are stored in array list. Then this for loop will print out the contents of the array list. So I think you remember this one, size and get. Array list dot size will return the size of the array list. Here there are 5 elements, so 5 will be returned here. So from 0 to 4, because this is less than, from 0 to 4, list.getI. Get 0 will get C++. Get 1 will get Java. Get 2 will get HTML5. Okay? So after getting each item, print out that. Okay? So this is the output. I will change this code. I'll transform this code into iterator interface. Okay? Using iterator interface, I will do the same thing. This is the same code from the previous page, but this time I used iterator here instead of for loop. So at first you need to import java.util.iterator, and in main method ArrayList is created same as the previous one. Then in the memory you can have this ArrayList. Okay, ArrayList is different from array, and this is ArrayList. And C++, Java, and these 5 strings are stored. And here, this is important. You must memorize this one. There is a pattern. When you use an iterator, then there is a pattern. So you need to memorize and just use it. At first, you need to get iterator. So iterator string, because these are strings. String should be here, and this is the name of the iterator. And then list is from this list.iterator. Okay, then this means that one iterator is attached to the list. You can think like that. So kind of pointer. This is an iterator iter. Okay, this is an iter. Because I have name here iter, then while iter has next, this means that iter points to something, okay, points to some item. Then this is true, right? Because now iter points to C++, so this is true. So iter dot next. This means that get next element. So this is the element, okay? So iter has this one, so get this one. So get this one and then print out. So C++ is printed out. Then iter moves to next. Okay. So has next and get next. So Java is printed out. Okay. So iterator iterates automatically. Okay. Once you have iterator like this, then you only need to use has next and next. Then automatically it will get the next element like this. Okay, so this is pretty easy one. This is pretty easy to go through all the array list. So from now on, I suggest to you that use iterator rather than for loop.